All right, this video is parametric equations, the second example for Unit 11. So we are going to look at this situation here. We've got our parametric equations here. Complete the table of values for t greater than or equal to -3 and less than or equal to 3. And then we'll sketch our graph and we'll find our rectangular equation. We're not going to verify this in the calculator for the sake of time. So for t, I'm going to have the following values: -3, -2, -1, 0, 1, 2, and 3. So I'm going to substitute in for each of my equations. So let's go ahead and find all of our x values. So x is going to be equal to 3 minus -3 squared. So that's going to give me 3 minus 9, which is -6. All right, and then I'm going to do the same thing for y. Oh, I said I was going to do all the x's first, didn't I? A little bit of consistency here, crazy pants. Me, not you. So then I've got 3 minus a -2 squared, which gives me 3 minus +4, which is -1. What is wrong with me? Okay, and then at -1, I would have 3 minus a -1 squared, which is 3 minus 1, which would give me 2. And then when I substitute in a 0, I get 3 minus 0, which is just 3. And then at 1, I would have 3 minus 1 squared, so that's going to give me 2. 3 minus 2 squared would give me 3 minus 4. So that's gonna look like this: 3 minus 2 squared. So 3 minus 4 is -1. And then, of course, I'm going to have 3, so x is equal to 3 minus 3 squared, so that's going to be -6 again. Okay, and then I'm going to do the same thing for y. When t is -3, 2 minus 3 is going to be -1. Then I would have a 0 here. At -1, I would have +1. At 0, I'd have 2. I'm sorry, I should have paused the video probably, and so you wouldn't have to listen to this craziness. But it's fine, you'll live. Okay, so now I'm going to plot all of my ordered pairs here on my coordinate plane. So -6, -1, -1, 0, 2, 1, 3, 2, 2, 3, -1, 4, -6, 5. Okay, groovy. So as you can see, this is going to be a parabola that's on its side here. Oh, sad face. Let's try that again, try to do it a little bit better. Okay, there we go. So our initial point, remember, we always want to put that on our graph. So our initial point is right here where we start at 3 because we're moving from negative to positive. So that's going to be at -6, -1, right there, groovy. And then, of course, it's moving in this direction. And then, of course, now we want to write our rectangular equation. So I'm going to erase this stuff. All right, so when I'm writing my rectangular equation, we recognize this because we've already done conic sections. So we know that this is an x equals negative something parabola because it's opening to the left. So when I solve for this, I can just write it that way. So I am going to solve this y equation for t. So that means subtracting 2 from both sides. And then in my x equation, I can replace t squared with y minus 2, and I can square that. And then, of course, I'm going to move this 3 over to where we're used to seeing it. It means the same thing, and notice, again, just like on the other problems, is that we are restricted between, we have to restrict our domain and range. So notice that for this particular problem, our domain is restricted at -6. and it's also restricted at 3. So I am just going to write that out. Technically, since we wrote our equation in this form, we don't really have to worry about this right here because that's automatically defined. So technically, our domain is just going to be from -6 to 3. We can write it that way. It doesn't matter. I'm just throwing that out there. And then our range, of course, is restricted to -1 up to 5. Okay, I'm sorry. I'm rambling a little bit today. We don't know why. All right, so that is how you do that problem.